This is our fourth video for Unit 9. Today we're going to be distributing radicals. And it's very similar to regular distributive property, where we have x plus 3 and x plus 4. We're doing the same stuff. We're doing the where we share it like this. You might sometimes hear it as the FOIL method. Now, before we do that, our first problem we have is square root of 3 times the quantity square root of 6 plus 8. Again, we're just doing the distributive property here, just like that. So when we multiply, the square roots are kind of like your variable. If you see how they both have a square root, I'm going to make that square root of 18. Now for the second one, when we do the square root of 3 times 8, I'm going to just write it as 8 square root 3. You can't multiply 8 with the 3 because the 3 has a square root, but the 8 does not. Now from here we want to try to simplify if we can. This actually does. This breaks up into 9 and 2, 3 and 3. So there's my pair. So this is going to become 3 square root of 2. Remember that goes in the square root. Plus 8 square root 3. Our second problem here looks like a problem we would do the FOIL method with. Now, before we start, notice how the 3 square, how this square root of 5 has a 3 in front. This square root of 5 doesn't have any number in front. We do know that if there is no number in front, it's 1. Just like if it was an x. You just say 1x. So we're going to put the 1 in front there, and now we can distribute. Again, we do 4 times 6, which is 24. And then we're going to do the 4 times a negative 1 square root of 5. Well, 4 times 1 is negative 4. Negative 4 square root 5. Now we're going to go here, the 3 square root of 5 times 6. Once again, the 3 is multiplied by the 6 to get 18. The square root of 5 just goes along like if it were a variable. And then finally we have our last part here. 3 square root of 5 times a negative 1 square root of 5. Well, we're going to do 3 times negative 1. 3 times negative 1 is negative 3. Square root of, now we're going to do the same thing. We're going to multiply the 5s because both of those have square roots around them. So that's 25. And now we're going to try to simplify here. Let's look at our like terms. We have this term and this term. Those are going to add together. So that gives me negative 4 plus 18. We're going to add negative 4 and 18 together. That is 14. Again, they're like variables, so you're going to keep the square root the same. I'm going to drop this 24 down and put a plus in front of the 14. Now over here we have that square root of 25. You guys know what the square root of 25 is. It's 5. Okay? So that's 3 times 5, guys. 3 times 5. Well, that's 15. Okay? 3 times 5 is 15. And finally, we're going to add 2 more like terms. We have a 24 and a negative 15. 24 minus 15 is 9. 9 plus 14 square root of 5 is our answer. our final problem is like a perfect square binomial, where we are going to want to write it out, write two of them, like so. Okay, so once again, we're going to distribute. So the square root of 7, square root of 7. If you need to, let's put a 1 in front. It's 1 square root of 7 times 1 square root of 7. That's going to equal square root of 49, or 1 square root of 49. Alright? If you know a shortcut, when you have two 7s, that's a pair. Your answer is 7 that way. I'm just going to write it out here. Square root of 49. Again, that's 7 and 7. 7 is in front. We do 7, the square root of 7 times 3. Once again, multiply the numbers outside. 1 times 3. That's 3. We move down here. 3 times this. Again, we're taking 3 times the 1. So that's 3 square root of 7 again. You see, I'm not changing the square root here. It's not changing because there's nothing with the 3's. There's nothing on those 3's after it. Lastly, we have 3 times 3. 3 times 3 is 9. We're going to do our like terms. We know 7 and 9 add together. And we know 3 square root of 7 plus 3 square root of 7 add together. We're going to add those together. 7 plus 9 is 16. Now again, adding your radicals. Remember, add what's in front. 3 plus 3 is 6. 6 square root of 7. Don't say 14 there. I don't change the square roots in an addition problem. And that's our final answer. Alright guys, you have a good day.